about me, so I have about 25 years of experience. I've been working on the embedded space, designing products right from devices, system on chips, and in the last 5 years in CTO Office in Wipro. I've been building technologies which are cutting across smart devices, which is wearables, industrial devices, handhelds, Internet of Things, robotics, drones, and image and video analytics. That's where my team is focused on. This today presentation I have kind of tailored. So I was in discussion with Krishna for the last 2 years in terms of the work he is doing here in terms of setting up a startup incubation, and then some of the ideas which we exchanged were Coimbatore being a place where there is heavy electrical and then pump sets and then textile industry which is actually close by. If you look from the Internet of Things or industrial internet, one of the prominent area which is having significant footprint in the business or solutions to come is discrete manufacturing. All that there is process manufacturing, discrete manufacturing, then transportation, healthcare, all those sectors. So discrete manufacturing is where automotive or components and parts get actually made and then assembled. So that's where I thought would be the right place to work on, and then I think he has set up a fantastic lab in a short time, and then it's glad to see that. And I would kind of give my view and opinion and experience on this area. So that's what has planned this about 20-25 minutes. So if you look from the world at 2020, so there's a lot of data. I mean, people have been talking about the number of IoT devices, connected devices which is in the market, and trillions of revenue which is going to come up. So what I wanted to see is start from where all this story starts, and then try to see what are the opportunities which we have in this space. So if you go see so what is Internet of Things? Internet of Things is nothing but we had earlier devices, factories which are all running independently. Now today we are talking about smart connected sensors. Earlier there were sensors existing which were all measuring temperature, pressure, or various parameters. People used to take readings, note it down, bring it to a chart or table, and then work on it. With the technology advancement, what we are seeing is all of them are becoming smart, intelligent, connected, and they are in small form factor. Advantage of that is you can actually realize much more value from the whole chain of this. So starting from the sensors which actually now can communicate this data automatically to the backend and then take some actions on. It can be embedded anywhere, and being able to talk to a backend system, and this backend system can talk to innumerous number of millions of sensors around, same factory, same plant, same shop floor, or across the shop floor. So that gives the power of internet or industrial internet, where you can make valuable decisions. You can learn from this and then apply learnings on top of it, AI and cognitive systems. So that's what is the whole value which is coming from the Internet of Things. So if you look from few of the technologies, so which is underlying this, this one is on the wearable side. So you see smart wearable which is happening. So how it's going to help is basically you'll see that there are plans like today BMW plant. Whenever every car actually which is manufactured which is different, the person who is working on that car will get a message saying this is what is the customization which is to be done, and then he is able to take it and move forward. In the consumer sector, you know that smart wearables are there are Apple watches, Moto wearable. There are a lot of locally available Chinese wearables which has already hit a peak of I would say peak of usage. But today we are seeing that industrial and enterprise wearable are assuming more and more important in various industry segments. So that's going to be the trend in the years to come, where that will be put to use in shop floors in enterprises. Now, sensor fusion. So what is sensor fusion? Earlier it used to have sensors which is monitoring one data. So it can be temperature, it can be pressure, it can be acceleration, all. Now what we are seeing is today with the technology we are able to, with the semiconductor process, we are able to integrate a lot of this functionality into one small sensor. That's why our mobile phone is so small where name the sensor, it is there. You have a camera, you have accelerometer, you have gyroscope, you have light detection, almost everything which is imaginable in that sensor which are all across. Old times when we were learning engineering, it will occupy one full work table. That's all integrated into one small form factor with application which is front-ending that, which is allowing you to do a lot more than what is possible. So that's how these new applications are built on top of it. So sensor fusion is one which has enabled this technology.
What is sleep, sir?
Can I take questions in the back, because I want to finish it within about 25 minutes time. You can reserve the question, we'll definitely have time for that. Okay. So then MEMS. So what happens is MEMS are micro or nano electromechanical systems. So these are today with the process technology we are able to embed those into semiconductor. So you can get a ST accelerometer or gyroscope as a small silicon chip which can be embedded into systems. So which is also helping in terms of larger integration and then making such system more complex and then more powerful. User experience. So user experience earlier is basically we will have a computer and then we will type some data, then some data comes out, then you have a printer and then we look at all this printer data and then go ahead. Today it's fully changed because you have the touch gesture and then you are able to interact in multiple ways with the systems which we are connected to. So that's giving a different way of working with this. So in 10 or 20 years back, if you had said that I can touch and do things in my phone, people would not have believed it's possible because you still need a keypad or very minimal function. Today you know that you can do all kinds of, there is multi-point touch, it's realizable. Now there is gesture which is coming where you don't even need to touch, you can just say that, turn on that light and that comes on. So that's another technology enablement which has happened. Biometric. So biometry also it's changing the way where earlier systems are, it needs to be a fingerprint or an iris scan. Today there are solutions available by which you don't need any continuous any single data point. There is a way to get a continuous biometry which is built into any of the wearable which you are having. So that's opening up. Say if you are looking at banking or such transaction, you can be just authenticating as you move through a corridor, a security a place or a laptop or any of the banking systems. Autonomous devices. So these are devices which are having its own intelligence learning algorithm which is able, which is making it do much more than what is possible in the yesteryears. Flexible electronics, we see today there are OLED or rollable displays, so that's another development which is happening which is enabling new user experience. Next please. Smart desk. So tomorrow we would see a smart desk is basically a very small tiny sensors which are embedded anywhere and you would be able to interconnect all this and then get all the information. So it doesn't need to be something which is really planned that way. You can actually fix it anywhere and have a very small minute sensors which can get all this information. We will be able to process it and do much larger actually value from the whole solution. So one major factor in all this development is power. So as you add complexity, you add memory, you add compute, what's happening is power profile is increasing. Now there is a need to have this devices or sensors or solutions which is very small. We want it to be as small as possible. So it's needing a good amount of power management in such a way that you are able to make these fine prints in a very small realizable factor. So a lot of developments has happened. If you look at any of the companies which is on the CPU space, whether it's Intel or ARM, they have scaled the power versus performance ratio over the years by using new technology, switching off circuits which is not needed, having dual rails of power supply. So that's really important because the amount of the battery technology has not moved as fast as the process technology for semiconductors. So there has been a lot of development happening to ensure that your devices which you have or sensors you have has at least enough battery to stay longer where you don't need to keep recharging it. So few of the other aspects which is apart from this the device or sensors is basically the mobile penetration. So you see that mobile is today in everybody's hand. And we have the technology available at far reach, whether it's urban or rural area. So that's helping. The power is there in everybody's hand, and then we can have application which is interconnected through this. which will allow us to control, like people are talking about solutions where you want to see a pumps to be turned on in agricultural farm, or you want to find out the lighting at home, the security. So all this is possible using your own mobile devices at your palm. So if look from other factors which has helped is compute, storage, network and bandwidth. So this we have seen that over years there has been a drastic drop in price points for this, which allows today, if you want to have a large storage, it is possible to, you don't need to build your own compute, you can even take it on loan basis as a service. You can do the same for the CPU, bandwidth cost is reduced drastically, and as well as more of network nodes which you want. So this is actually really helping, giving the power for enabling larger application, larger solutions, and being able to get more from the data. So tomorrow when you're talking about industrial internet revolution, you will have millions of sensors, so many machines interconnected, all put together. You need to have ability to fetch data from all of them. You need to have storage of this data. You need to be able to have processing capability. All this is possible because today all this power is available. There has been a drastic improvements or cost reduction in all this basic elements. Data. So now with big data comes a problem. So but there are tools and technology available for big data analysis, because having the data is good enough. There is a report which says that 75% of the data which is coming from all these sources are never used, and nobody is actually even looking at it. And there is very less because nobody has the time bandwidth to look at such data. Now this is about discrete data. Look at video or image data which is coming from various sources. There are security cameras available, and then various other monitoring. You have to have a system by which it's intelligently able to monitor and only bring you the incidents out of it. If you have people looking at this data, or you want some application to run on it, it is going to be humongous task to make sense out of it. So today there are tools and softwares and applications available by which you can just put the data in, and whatever you are looking for, if you have fine-tuned in such a way that the relevant information is needed, it can come out to you and you can take action on. So this is from the technology side. This is how I see as evolution, which has really helped to a point where we are. There are still challenges in terms of building that application and making it the right business model. So we will come to it in the further slides. So IoT system, overall ecosystem is highly fragmented today. So you have at the bottommost level, there are components and components manufacturers. There are semiconductor devices like SoCs, RAMs, flash, memory, and companies which are in the OEMs for these. Then there are devices. There are companies which are manufacturing the next level, which is taking these components and making devices out of it. Go to the next level. Then there are connected device platform. Then the connectivity. So connectivity is basically the connectivity standards which is there, the protocol which is coming with it, and then the sort of communication providers like the telecom companies. So they also have a find it, because finally this data has to be transported from a point where this data is being generated to a point where it's being consumed. So that's the beauty of having the cloud, because we can have the processing and capability which is learned from somewhere. There are servers which are sitting in Singapore for Amazon. So there is a need to have this data to be transported in an effective way. So there is a need to have the connectivity. Then the platform, so there is big data management, real-time data visualization. So there are platform players which are having solutions on this data management. Then applications. So if you look from all this side, then there will be point applications. Some of the applications we talked about. There are people who are developing application around using all these elements. So some of them are from various partners. They integrate put together and then say I have a point application which is addressing. So that's the overall IoT ecosystem, and SIs are cutting across. System integrators like Wipro, TCS are all cutting across all these solutions. So they work with different stack providers, and they integrate this and bring up the solution, whether it's for IoT or smart city or industrial internet. So some of the examples I wanted to highlight before we step into industrial internet. So these are consumer IoT use cases. So one of them is about Philips light bulb, where you can adjust the color and hue and then control it using a mobile app. There are wireless music systems from Sonos and BOSCH today, which you can control using internet. And this is a T-shirt. So now wearables are coming with a lot of sensors embedded, which allows you to know how much of what's the calorie, how's your heartbeat, how's your exercise regimen, and all that. On the enterprise side, again, there are examples. So this is a smart vending machine. So that vending machine manages by itself and orders what is actually going out of stock. And this is processed. So again, this is smart transportation, is basically where you can charge your car using a mobile application. Next. Industrial Internet case, there are many. So this is a company called Joy Global. So they are having these mining machines. So it looks this is actually a real mining machine, and these machines manage that whole area automatically. They are connected, they talk to each other, and then perform the task. There are robots also, like if you heard about some of the cleaning robots. So these are robots which comes after people leave office. It communicates with each other. First one is a scrubber robot, a cleaning robot, then there's a scrubber robot, then there's a cleaning robot. All of them communicate with each other and then say at which point it's not clean and then you need a better scrubbing. So those are the solutions which are being built in the industry, this area. And smart wind turbines, and then a lot of other examples of industrial internet. So next. Just to enter into it, so industrial internet is, if you look from industrial internet point of view, so industry 4.0 is one which is being talked about, and factory future is something which is defined by IAC and industry 4.0. It's a German initiative. It started as a German initiative a few years back. The idea was to bring all the manufacturing companies within Germany to the new technology, digital and connected, and then get the value out of connecting all these things. So if you look from the why 4.0 is basically first industrial revolution is where water, steam powered mechanical manufacturing facilities were around 1800. If you look, the second industrial revolution was electric powered mass production, where you have the automobiles, cars, and all. It started around 1870. Third is where IT was being used. So there are PLCs, there are robots, and all that. Fourth is what is the cyber physical system, which is being talked about, is where all these technologies which we are talking and AI and cognitive systems are going to be put to use to ensure that these plants work and they deliver better value. This is an definition of given by IEC. It's not my definition. So factory of future is majority of manufacturing plants and production facilities are putting into place systems that will make it adaptive, connected, analytical, and more efficient. So this is a new industrial revolution called factory of future. So what are the few key characteristics of the factory of future? It has to be adaptive, because factory of future will mean that there will be changes in the workflow, the factory, the offset, and what is being told today is from a mass manufacturing it will become customized manufacturing. So the factory should be able to automatically adjust production cycles and realign, fully connected, analytical, and efficient. And it is characterized by complete automation, where new technologies, devices like wearables or field devices are used to enhance the manufacturing productivity. And it's a convergence of, so you have the infrastructure, which is the mechanical assets and equipments, and building on top of it, bring the digital age, the data abilities, sensors to make better sense of the factory. And here the key is real-time availability of information, because if you are having all these systems available, still if you are not able to make real-time decisions, then it is not giving the right value. That means your whole supply chain, you should be able to interconnect and find out if your scheduled a task tomorrow, your parts are supposed to come, there are certain things which is not ready. You should be able to know in real time, saying that how all the systems are getting integrated, how it is moving in such a way that you are ensured that your work is going to start at the specified time, or if there is a delay, how we can replan it. So that means even the subcontractors or the vendors who are supplying parts and assemblies to you, you have to integrate to their system and be able to find out how their delivery is going, how their QC is going, so that your parts are shipped, and in the shipment you may have to find out that it's in transit, it is coming in time for your assembly. So what will be the opportunities and benefits? So this will mean that you have vastly improved operational efficiency, which will mean that improved uptime, asset utilization, and predictive maintenance and remote management. So today we see actually maintenance is such a way that there is a breakdown maintenance. When you have something which is down, then you go and attend to it. Then proactive maintenance. Proactive maintenance is saying that okay, you go and then you take your automobile car to a workshop every now and then. They say that 15,000 kilometers you have to change all these things. 30,000 kilometers you have to change the brake, there is a cable. 50,000 all the tires to be replaced. It is not looking at what is the condition of the tire or condition of this. It is a fixed regimen where you blindly go and apply certain rules to ensure that it doesn't fail in the field. It may not be the right way because some of these parts or stuff which is put into these devices can actually, this equipment can actually last more. So how do you look at a failure? So can a system or a battery say that okay, I am going to fail in next 15 days or 20 days, rather than saying 4 years over now, when you go to the workshop, you'll say that you better change it. I can't tell you that your car will break down in the midway somewhere. So that kind of systems will allow that less maintenance, and you can maintain what is needed. So the cost of maintenance also will reduce. Now, emergence of outcome economy here, what is said is today you are actually paying for the plant, process, software and all that. How can you ensure that the payment is basically based on an outcome? So you have a facility and based on an output which is coming out of it, you make a payment. You are not really looking at how the whole system is connected, how it's there. You have a defined set of parameters, based on the specification, how it's done, you make a payment. Collaboration between humans and machines. So how can we ensure that machine and the plant, people who are working in the plant are able to interwork each other, know what is happening, and then again at the supervisor level, he has a visibility of how the plant and the whole functioning is happening. And business shifts from product to outcome. So basically the guaranteed machine uptimes and shop floor could be something which can be outsourced to a company which is providing such a service, saying that okay, I can automate entire plant. So say that okay, entire plant is automated. What is SLA is basically ensure that the plant is operational with very less breakdown. If there is a breakdown, you are able to have an SLA of fixing within certain norms. So that would be kind of the business model which will evolve. So this will mean that actually factory future will increase the global competitiveness. It will require unprecedented integration of systems across domain, hierarchy, and life cycle process. Quickly, I will touch base on a couple of slides on Wipro's work in this. So we have our own IoT solutions. I don't want to spend too much of time on the platforms and examples because I think you have heard enough from morning. So this is basically what we have implemented. A solution is for a remote asset management. It was one of the companies which owns Earthmover. So we have put a sensor to monitor it, its service, how it's performing the field, and today I believe around 20,000 such machines are there in the field which are communicating the data back. We are able to make information out of it and then plan maintenance cycles and then find out what is really going on in the field, even plan the schedule, productivity and schedule of utilization of these machines. Connected mobile platform is basically a solution which we have a handheld device which is used for various, it can be used in factory, in the field as a connected mobility platform where it talks to the backend system and is able to bring information on a tablet and process it and actionable for people in factories and field. Healthcare monitoring solution is something which we have built from scratch. So this is a work which we did about 3 years back, where we have built wearable devices for healthcare, and the platform is called iShoot Health. It is for chronic disease management. We have offerings for cardiac disease management, for pregnancy monitoring, and diabetes monitoring. So this solution comprises of wearable devices, medical grade, gateways which are home gateways and mobile gateway, remote monitoring, and then various application and backend analytics. So this is another case study. So we have recently partnered with Artisan, who is having a platform called Detonix. It's a IoT platform. So this is another use case from them for an automotive component manufacturer, how they have implemented. So this is really a use case in the plant where they are able to monitor various equipment within the plant and then able to give value to the whole plant process. So, challenges in IoT is today evolving architectures. So there are many architectures, many solutions there in the market, and it's a bit confusing, what to pick and then what to bet on. New technologies, because some of these technologies are still evolving. So it's possible that some of them may not really reach the peak and can drop off. So which technology to invest on. Business models, it's still being worked at. So there are questions asking, what is the value which I get out of doing this? What's the investment to be put? Who should put the investment? So there are new business model and untested waters here. Global adoption is still not at a large scale. There are pockets of adoption, and mainly most of the examples we talked about by large OEMs where they have implemented their own plan and they are trying to replicate it outside. Let it be GE, Siemens, Rockwell, or such and such. Lack of standards. So what's happening is any system like this, you would want it to be interconnected to a different system. Tomorrow, you don't want to be tied up with each pieces of it such a way that you are stuck with a component supplier or a platform provider at every level, where for some reason it can be business or some other closing down, your whole solution is at risk. So there will be there have been too many standards or lack of standards. So that is evolving today. There are various standard committees which are working in terms of coming up with a standardization on how these solutions end to end will communicate, right from the device all the way to the back end and forth. Security and privacy concerns. Now, one of the gentlemen here asked about, so I am giving this data, where this data goes, who is going to have control of this data. I don't want a competitor to look at this data, and then I want it to be preserved such a way that only I can have access to it. So there are standards and encryption standards in work, but today it's again in a gray area, an open area. So it's to be watched and looked at. So when you are setting up a system, you have to ask that question to ensure that your data is safe and secure, and then you have only access to that data. These are some of the prominent standard bodies which are working. So there is an Industrial Internet Consortium driven by biggies, Open Internet Connect, RC Alliance, Thread, and IEEE 2413 standard body is working in terms of an architecture framework. We are working with them to see how they can kind of guide or adopt something which can be applied across. And one of the authorized representatives participating in the IEEE 2413 standard committee. So we need to see how the whole thing will evolve and then reach to a stage where some of the problems that you have can be easily addressed, where you can buy it as a service rather than having the pain of finding which board to be taken, how to connect the sensor, build it up, stitch, and then what value to be seen, and then really do I get that value or not at the end. So, but it's good to start working on, because sooner or later the whole industry will catch up, and we need to be globally competent in this industry. So it is the right time to really work and then figure out that equation before the world moves to a new standard where we are left behind. And all the technology element, fortunately, is available today for us. All of them are within our reach, and if you look from manpower and other consideration, it is much less costly compared to any of the developed countries. So we have the whole tools and technologies available. We have the resources possible. So my suggestion is we have to experiment, figure out this, and then come out of it and come with the right solutions and business model. And I'm sure FORGE and Incubators IoT incubators like FORGE and working with industry, we would be able to really see the benefit of industrial internet, especially for needed industry, which is small and medium industries, because the large corporates or large companies will find their own way to come out of it. For the SMEs, it's really important that work closely with academia and institutes like this to make the right, I'd say get the best out of the world. Both worlds. Okay, thanks. I have a short video. If you can run through.
In this video, we're going to show you how big, bold technology leaps are enabling sustained productivity gains in UK engineering, manufacturing and distribution, and how you can join in. Right now, in Europe, raw materials, parts and components are making their way independently through the production process, with machines, products and sensors spontaneously communicating with one another, making decisions without direct human intervention. The Advanced Manufacturing Research Centre is backing that vision of the future by building a brand new £40 million factory in Sheffield.
So we're bringing together industry experts, academics, backed by government to really focus on innovative products for reconfigurable manufacturing. We're here to develop the understanding, adoption and deployment of them throughout UK industry. And we're looking at augmented reality, taking information from the CAD system and displaying it on parts like a wing. And 3D printing is changing the world in terms of the ability to prototype much quicker than we've been able to in the past.
That sounds great, but how can businesses get involved?
We work with businesses from large OEMs to tier 1s and SMEs, so really we take inquiries from absolutely anybody.
One of the new technologies that's captured everyone's attention is virtualization.
The idea is a simple one. You take the miles of conveyor belts, motor drives, scanners, elevators and machine tool components and raw materials, and then you put all that information into a software package and create a virtual factory, an exact replica in fact of the real physical factory, because the virtual factory enables you to take a real-time big picture view, identify areas where you can improve efficiency, cut out waste and prevent problems occurring in the real factory. But the biggest thing virtualization delivers is the ability to add more innovation, more flexibility and most importantly more productivity. Today every sensor button and monitoring device has the potential to become a participant in the Internet of Things, each with their own IP address. These so-called cyber physical systems will eventually enable machines and workpieces to communicate with one another and make decisions within the process. Employees can use virtualization to check the product meets the required quality standard and is ready to be shipped to the customer. Today, your IT infrastructure is becoming more important than your raw materials, machine tools and physical assets. Cloud technology is enabling infrastructures like this to become part of a global ecosystem of suppliers, partners and customers. A connected supply chain speeding up decision making, collaboration and innovation. The companies who thrive in this new world may not be the biggest right now, but they certainly will be the most flexible in the future, with the ability to customize the product to meet the ever-changing demands of their customers. Customization is great because it requires zero inventory, everything is made to order and there is no waste. The step beyond customizing is individualizing. An entire product is made just for one customer. Like most of today's early adopters, we too started by creating a virtual 3D factory using an easy-to-use software package, and this allowed us to experiment with different setups. But there are problems when you start harnessing the Internet of Things and deploying cyber-physical systems. You generate mountains of big data.
Fortunately, smart systems are now available which make sense of that big data, delivering the factory decision makers the information they need. A typical text message might read, "Motor drive 10 on conveyor belt B requires maintenance. Please press confirm to order the part." Creating your UK factory of the future is going to require skills. People, engineers, technicians. But what skills are going to be needed? Where are these people going to come from? And who's going to train them? To answer that question, I travelled to Coventry to one of the high-value manufacturing catapult centres, the Manufacturing Technology Centre, where they've just opened the Lloyds Bank Advanced Manufacturing Training Centre.
There's no point generating the technologies unless you also generate the people who can use those technologies. The engineers and technicians that go through this training centre will have a grounding in all of the old technologies, but then they will have all of the skills needed for the new technologies that we're developing.
So how do our engineering skills in the UK compare to those in the rest of the world?
I think the problem we have worldwide is there aren't enough engineers and there aren't enough people coming through with the right skills to really drive the industry forward. The unique thing about the centre is the access that we've got to all of the new technologies that we're developing as part of the Manufacturing Technology Centre itself. And the fact that we've got the people that are developing those processes that can teach the guys in the apprentice centre and really make sure that they've got the skills that they need for tomorrow's industry and not just the skills that were needed for yesterday's industry.
Creating the UK factory of the future is a big idea. No one company on their own could achieve this. It requires collaboration on a grand scale, a revolution in the way we think, communicate and collaborate.
We hope this short video has inspired you and given you an insight into how a revolution in new technologies, Industry 4.0, can enable you to accelerate your innovation, respond to customer needs and drive up productivity.
SIEMA can help you review your options, overcome challenges and provide the technology, equipment and engineering expertise to build your factory of the future.
Give us a call, we'd love to talk to you.
One thing you told sleep set. I need to know what is sleep set. Next thing is that you are telling that sensor will be used to track the situation of the or condition of the machines or process environment. Something happened to sensor, how we can maintain the sensors. That we should know. The third thing is that to make the live data, you are telling everywhere sensors. Why RFID technology will not be used for that? See, I want to make my material as a smart material. So for that, what you suggest? Whether I can go with RFID or sensor?
I'll answer the reverse chronology. So RFID is a technology used to track a material, a person or an object. Okay. So that means if I have an RFID tag stuck on me wherever I go, we can track if we have sensors. Or if I put it on this mic, anybody carries it around, we can find out. Now, when you talk about sensors, you want to find out some properties, its working properties. It could be temperature, acceleration or something, right? So that means that you need to put a sensor. It's not RFID. RFID is only giving you an identity to say that this device is moving, or if you go to a shop floor where there is a something actually you have bought something, it is moving from one point to another.
Say example, to get the right field identification number in automobile industry.
Yeah.
So if I use the RFID.
So that is the tracking. Yeah. So it cannot tell you how the vehicle is performing or what is it. It is only associating a number to that bin. Okay. So that's all possible with RFID. What is the second question?
My second question is that you are using sensors everywhere, okay, to make the function very easy. See, if something happened to the sensors.
Yeah.
See, for example, in particular machine, you have integrated 5 sensors, okay. Out of 5 sensors, one sensor got come out, okay. Or if the sensor sensitivity is going down, how you track and how you are doing the maintenance?
So it is. It's not a, I would say, a new problem. If you look at an aircraft industry, GE or GS put sensors on all the aircraft engines just flying, and they are collecting this data live, so that before the aircraft lands, they are prepared for maintenance. So what they do is, so depending on if you want to monitor certain things in a normal way, you know that if the data is coming wrong or you are missing data, that's one way of finding out. If you want to really double proof for the critical applications, then you have to have backups. So there will be fail-safe solutions available, by which one fails, no other is able to detect and then send the data saying, okay, there is a mismatch between these two, you better act on it.
And also, see, regarding the sensor, you told one common sensor, instead of single sensors, instead of 5 sensors, one common sensors will be used in future. Okay. See, how you will get the data of, for example, viscosity of the hydraulic oil, and how the vibration of that particular bearing, how you will integrate it?
So, see, the example I gave was where you are able to integrate a lot of these sensors onto a very small form factor, so like a mobile. But even though it's there in a mobile, each of these sensors are separate. Now, you have to, for sensing the most critical aspect is you have to be close to the problem area where you want to sense. So that is not going to be going away. So if your problem area is scattered around, I need to be reaching every point, get the data. That's not going to change.
Then sleep sensor, that is my final.
Sleep sensor?
Sleep sensor.
Sure.
Sir.
Sure.
Oh, okay.
What is it?
So basically what is happening is you know about this wearables, right? Today people are wearing these gadgets where you're moving around, you can find out whether you're walking, how much of steps you're making. So same way now people have embedded those sensors into sweatshirts or exercise this. So that is going to take your heart rate and various data and communicate back to so you can know your exercise regimen. So it's used today. There are solutions used in sports. It's used as an aid where how a person who is in some of the sports game, the coach wants to know or a manager wants to know if that person, the critical player is too exhausted, he wants to pull him back. He's using the data to do it. He knows that okay, he's really exhausted and then he needs some break. So he can use this data, how many times, how fast he was running, how was this actually performance the last 15 minutes based on the data.
I have a question.
Maybe one last question.
Okay, please.
Okay, everybody is talking about IoT, but there is, as technology grows, there is a big problem about the technology being hacked. Based on your experience, how do you think we should be going about it? Because any technology will have its vulnerabilities. So, and here it's more critical. I have sensors in my house where I've got everything, all my personal information is there, and that technology can be at the hands of a hacker.
So it's no different from a IT problem where your bank account is hacked.
Correct.
So you have more probably deposits in the bank rather than in the house sometimes. So it's true that you have to ensure privacy and security. So there are standards coming up, and most of the solution has inbuilt security.
Okay.
But vulnerability exists. So in all the apps which we are using in IT as well as this, so it is only so. As time moves from one solution to another, there will be advancement happening. There will be hackers who are behind this. So it's catch-22 situation. So there's no definitive answer, but you have to really look at the security, encryption, and privacy and protection of data, and all this scheme of things. So if you are the consumer, you should ask those questions and be confident that it is there and that it's being taken care by the provider. Today, when you are getting your banking account and you're logging onto it, it's possible that someone else can hack into it through your computer or any other device, because this is all finally in a server which is sitting somewhere. It's the same. So your factory can be hacked or your house can be hacked tomorrow. Thank you.